Let's start. So we have been discussing what is system software. To begin with, we discussed the difference between application software and system software. We looked at the difference between the two, and we looked at the detailed examples of application software. We moved on to system software examples, in which so far we are done with discussing what are device drivers and what are operating systems. All right. So continuing it from this point onwards, the examples that we have to discuss today are utilities, linkers, and compilers. So let's start from utilities. What are utilities? You might have heard this term in your everyday life, utility or utilities. Now, what are utilities in context of software or system software? Basically, utilities is a set of those programs that would do a task which is related to the maintenance or upkeeping of the computer, making sure that the computer is running free of errors without any trouble. So any such program which enables the computer to run trouble-free without any problem can be put in the category of a utility program. If you look at what's given here in the description, it says software designed to do a specific task to maintain and control the computer's resources. For example, antivirus, disk repair, security, these are all examples. Yeah. So if we look at the examples given here, such as if we take the example of an antivirus. You know what is an antivirus program? You have any idea what is an antivirus program? You know what is a computer virus? Okay. You wanted to say something? Exactly, good. So, what is a computer virus? It is just a program which is created to disrupt the normal functioning of a computer system. It is created with malintention to, in some way, disrupt the normal working or functioning of the computer system. In what way? That it may cause some sort of a harm to the data which is stored on the computer or the software which is stored on it, or else it may even affect the working of the hardware. It may destroy the hard disk, okay, and it may corrupt any program or programs or the data which is stored on the hard drive or on the computer. So wouldn't such a program be a problem for the computer, or wouldn't it be a hindrance in the normal functioning or working of the computer? Yeah. So what is an antivirus program then? An antivirus program is a special type of a utility program, or it is an example of an operating system, sorry, a system software that helps us to detect the presence of a virus or viruses, and would also help us remove it from the computer, to save the computer from that risk, or to save the computer from the risk of a virus affecting or infecting the data and the programs that are stored on the computer, or in some way disrupting the normal functionality of the hardware. Yeah. So remember, I just when I defined what is a utility program, I told you that it is that program, or it is a set of those programs which help you maintain the computer in some way, which make sure that the computer is running smoothly without any problem, without any trouble. So antivirus program is just one example. Other examples could be such as disk repair. Disk repair would be a program that would help you in organizing data on your disk in such a way that uh, it remains stored in an organized way. And uh, if it is not organized, say for instance, if the data which is stored on the disk is not organized, it will make the computer slow. It will make uh, the process of accessing data and storing the data onto the disk slow. So from time to time, there's a need of ensuring that whatever data or programs are being stored on your disk, when I say disk, I basically mean the hard disk. Okay. So whatever the data or the programs that you store on your disk are stored in some sort of an organized way, which will make sure that whenever any data or program needs to be accessed, it can be accessed efficiently without any delay. All right. So the access times to the data or the programs can be reduced, and so in that way, making the computer keep on working efficiently. If the data is not organized on the disk, then that would cause delays in the time that it would take to access any particular data stored on the disk, and you know uh, open it up for the user so that the user can use it, whether it is a program or it is a file that you saved at some time earlier. Is it making sense? Yeah. Okay. Security. Any security program would be included in the category of utility program because it would help you improve the security of your computer. Security from people who would otherwise like to get hold of the data which is stored on the computers illegally, maybe through hacking. Yeah, exactly. Like cybercrime. Cybercrime is a good term. Yeah, and cybercrime is a term that we normally associate with all sorts of crimes that may be committed by people when they are present on the global network such as the internet. Yeah, that is what a cybercrime would be. So hacking is a cybercrime. It is an example of a cybercrime. And what is hacking? Hacking is an illegal act of gaining access to somebody's data uh, by breaching the security on the computer, getting hold of the data, and then misusing it in some way, with the intention to bring about a harm to the person that the data belongs to. Yeah. So if you can uh, put in certain measures, certain programs that would help you to ensure that your data cannot be illegally accessed, such as you can make sure that you implement certain firewalls. Firewall is a way of protecting your computer or the data against illegal access. All right. So just a few examples that I gave you regarding what is meant by making sure that the computer is kept up and running without any problem, without any trouble. Why? Because if the computer goes out of order in any way, that would be a problem for the user, and it would also create a problem for the data which is stored on the computer, the user's data. If you're not able to access it, or if it goes corrupted, then of course it will be a problem for you. So utility software are all those programs that make sure that your computer is maintained properly, it is kept up and running without any trouble, without any problem. All right. I think one of the most common examples that we discussed here was the antivirus program, because virus is a common threat. Yeah. Okay. So that's that as far as utilities are concerned. Let's now move on to what is a compiler and what type of a system software is a compiler. Well, before I can get into the detail of what a compiler is, I will have to give you a bit of a background of a few things before we can sort of get to understand what type of a program a compiler is. Okay, well, you must have heard about programming languages. We know what is a computer program. How would you define a computer program? Well, we have just seen that programs may be divided into two categories, such as application software or and system software. Okay, or software may be divided into two main categories: application and system. If you were to define a program, you can simply say that a program is a set of instructions. It is a set of instructions that tell the computer what to do. So when we talk about a system software such as the operating system, the main purpose of the operating system is to tell the computer what to do and how to do it through the instructions that are there, which are part of the operating system. So why am I talking about this? Because this is going to lead us up to what are programming languages and stuff. So tell me one thing: where do computer programs come from? Does somebody create a computer program? Does somebody develop a computer program? Okay, and uh, what do you call people who develop or make computer programs? Programmers. Very good. Programmers write computer programs or develop computer programs or software. Yeah. Now, don't you think that programmers would need some tool to develop a computer program? Yeah, like if we know that if we have to, we have seen so many examples of application software. We know that if we have to type out a letter, or we have to do something that relates to text, then we can use a program like a Microsoft Word or a word processing software. Yeah, so that's the tool that I'm using to get the job done. Now, if a programmer has to write a computer program, he would need a tool to do that. What is that tool called? No. Somebody just said that. What do programmers use to create computer programs? Programming languages. Okay. Why are you guys confused? Okay, so a programming language a programming language is what a programmer would use to write or to create a computer program, right? Now, does anybody know the name of any programming language? Okay, Java, Python, C++, JavaScript, C, Visual Basic, quite a few. Yeah. Now, I have a question. Although I have asked a few questions, but I have another question, and that is, if the purpose of a programming language is to develop a computer program, why do we have so many different programming languages? Very good. For different purposes. Makes sense. Okay. I think you mean to say that. I think what you mean to say is that different programming languages may be used to create different types of programs. Okay, not bad. Yes. Okay, you are saying that it is for the ease of the programmer. Um, well, we can say that in a certain context, but that is not really, what the reason would be why so many different types of programming languages exist. So there's a very simple reason for that. The simple reason is that every programming language is suited to developing a specific type of a computer program. Every programming language. Why do so many programming languages exist? Because different programming languages are suited for developing different types of computer programs. Hence, it's not that you can use one programming language and you can create all sorts of different programs using that. All right? For example, let's put it this way. The programming languages that would be used for creating games will be different from the ones that would be needed to create uh, databases, okay, or the programming languages that would be needed to program maybe robots or program computers, from the programming languages that are used to create different types of application programs. So games is one type of, a type of a program. Games are, by the way, computer games are computer programs. Yeah. uh, Operating systems. So particular languages suited for developing only operating system programs or system software. Others are suited for developing different types of application software. Some might be suited for developing programs that are highly graphical in nature. Others will be suited for developing programs that are used to store data in the form of data records. You see? So basically, yeah, and one more example I think I should give. Programming languages that are suitable for developing and designing web pages. So every programming language has, or a set of programming languages have a certain purpose, or they are suited for developing a certain category of programs. So any programmer, when is confronted with a certain task, okay, will first look at the nature of the task or the type of program that needs to be developed, and accordingly will make a choice for the programming language that best suits developing that kind of a program. Since he knows that every programming language is not suitable for developing every type of program, so if he has to develop a system software, there will be a separate set of languages. If some application software or program needs to be developed, there will be a separate set of languages. Graphics software, graphics programs, web page development, and so on and so forth. All right. So accordingly, a choice for a programming language will be made. Hence, this is the reason why there are so many different types of programming languages. You just named quite a few. All right. Okay. And by the way, of course, that is by no means an exhaustive list that you gave. These are just a few examples that you gave. But there are tens of other examples of uh, programming languages. Okay, well, let's just take this discussion further a bit. We'll have to expand it further. So I would be needing more space to write a few things. Okay, so programming languages may be classified into two types. You may draw this as well. It would be like a simple kind of a flow diagram. We may classify programming languages into two types, namely low level and high level. So programming languages, as I was saying, may be classified into two types: low level programming languages or high level programming languages. Now, what do these basically mean, or what are these two categories all about? Before we get into any detail of this, tell me one more thing. What is the language of the computer? Binary, binary, machine. Binary or machine is one and the same thing. Very good, excellent. So the language that the computer understands, the form in which computer understands everything is called binary language or machine language. Okay? What is machine language made up of? Zeros and ones. Very good. Zeros and ones. Hence the name binary. Bi means two. Binary, yeah, binary. A language that makes use of two numbers. Okay, binary. Only two numbers, 0 and 1. There is no third digit. Hence binary language. Okay, computers understand everything in binary language. What do I basically mean by that? Well, when it comes to us humans who are the users of the computer, we know what alphabets are, we know what special characters are, we know what numbers are, we know what is a picture, we know what is audio, video, animation, we know what all these forms of data representation are. If somebody shows us a picture, we would know it is a picture. Yeah. If somebody shows us text, we will know it is text. But does the computer know all these? I mean, is the computer able to differentiate between them like this, the way I describe it? Like, we know what is a picture or what is text and whatnot? No. For computers, everything is ones and zeros. For computers, everything is ones and zeros, the language of the computer. So when we put in any data into the computer, when we input anything, it takes the shape of ones and zeros. Whenever that input gets processed, ones and zeros. Whenever something is to be produced as output or as a result, ones and zeros. At the hardware level, it is all ones and zeros, be it a picture or text or video or audio, whatnot. So, computer understands binary or machine language. Do we understand binary or machine language? Very difficult. If at all we were to make any sense out of binary language, it would be very difficult for us to do that. Do you know that when people started programming computers, they initially used to program computers using only binary language? All those programmers had to painstakingly remember combinations of ones and zeros to represent different instructions. That is how it all started. Okay, so initially the computers were programmed in a machine language, in the language of the computer itself. Now, since it was very difficult to do that, Imagine, why would it be difficult? Well, there are two or three points that come to my mind, and that's the way they are understood, world over. One is ones and zeros as as a language is not close to humans, is not close to human understanding. So it would be very difficult for us to use them. Not only would it be very difficult, but it would also be very time consuming to code like that or to write instructions in ones and zeros. The third point that is important here is that uh, the chances of making error would be great. And imagine if all you could see on the screen was ones and zeros. If you were to miss out a 1 or a 0 from an instruction or swap it around, it would change the meaning of the entire instruction. So in a huge, I would say, combination of ones and zeros, how difficult would it be to trace any error made? How would you figure out where you made an error, where you missed a 0 or a 1, or where did you swap the position of any two ones or zeros? Very, very difficult. So not only was that it was difficult to remember, it was time consuming to write instructions, but it was also very difficult to correct if you made any errors in writing the program statements using ones and zeros only. Hence, since technology has been going through a stage of evolution, going through a process of evolution ever since computers have come around, computer scientists started thinking about ways and means whereby they could somehow ease the task of the programmers of creating computer programs. It was then that they came up with a programming language. Okay, by the way, machine language or binary or machine language are examples of low level languages. Both, I mean, not both, actually, it's the same. Machine language is an example of a low level language. Whether you say machine language or binary language, it is an example of a low level language. Another language that they came up with was assembly. Assembly was also a low level language, but how was assembly better than machine language? Well, assembly language replaced very difficult instructions that you could have written in ones and zeros only, uh, replaced it with English abbreviations or English like abbreviated words, such as I would say STO for storing, ADD for adding any values, okay, SUB for subtracting, MUL for multiplying, and so on. Now, if you were to write a programming instruction where you could use abbreviated English letters, don't you think that would be far better than writing only in ones and zeros? This would still make the task easier. Do you agree with this or not? Because this is something that we can at least relate to, and there is a chance that we would remember it. We would remember a certain abbreviation or something. And by the way, these were collectively called, what were they called? Who can pronounce this? These were called mnemonics. M is silent. M is silent. These were called mnemonics. So these abbreviated English words called mnemonics were used to write programming instructions using assembly language. Clear? So assembly language made the task of writing computer programs slightly easier compared to having to write instructions only using ones and zeros. Do you agree with that? Yeah? Okay. But this led to one problem arising. Can anybody identify the problem? Writing instructions using mnemonics and assembly language created one problem. Yes, exactly. Very good. We have been talking about the fact that computers only understand ones and zeros. So, if a programmer would write instructions using assembly language that would make use of mnemonics or abbreviated words, how would the computer know what they are? Sorry? Yes. I mean, it would be impossible for the computer to process these. If you wanted the computer to be able to process these, you had to do something for that. No problem. Okay, so the point that I was just making a while ago was that the computer would not be able to understand what mnemonics are. Then how would you make the computer understand these instructions? Well, this is where by the way, we are moving closer to what a compiler is through this discussion. We would have to make use of what is known as, or what are known as translation programs. Well, you will have to make use of a translation program with assembly language, the purpose of which will be to translate or convert in programming instructions written in assembly language into machine code or machine language before the computer could store, understand, and process the instructions. Hence, what computer scientists thought was, well, okay, if we are, making the process of writing a program easier for the programmer, it would become difficult for the computer because the instructions would not be in a form in which the computer can understand. So what can we do? Well, they said, okay, well, fine. We can create a translation program with a particular programming language that will take those statements written in a language like an assembly language, convert it into ones and zeros, the binary language, so that it can be stored and run on the computer. This is where the concept of translation programs was born. Yeah? Let me give you a simple everyday life example. Let's try to draw an analogy here. Um, say, for instance, I know English, you know French. Let's put it that way. I don't know a word of French, and you don't know a word of English, hypothetically speaking. If we want to communicate with each other, how can we communicate? Well, we can put a person in between who would act as a human translator who knows both the languages. A person who knows French as well as he knows English. So when I speak in English, he will translate my English into French for you so that you can understand it. And then you will give your response in French, which I do not understand, but he knows. He will translate your French response in English for me to understand. So a translator in between would make it possible for both of us to communicate in our own languages. It is exactly this what the role of a translation program is. It's a program that translates instructions written by a programmer in a language, okay, or in a certain language into machine code for the computer to understand and carry out the instructions. Is this clear? Now, one example of a translation, the example of a translation program that converts instructions written in assembly language into machine code is called assembler. What is it called? And assembler is what? It is a translation program. It comes packaged with assembly language. So when you install assembly language, the assembler would be there behind the scenes. And when instructions or statements are written in assembly language, the assembler would convert those instructions into machine code or binary language so that the program could be understood and processed by the computer and executed. The statements or the instructions could be executed and the computer could get the job done. Okay, it all did not stop here. There was another step still. Now, ever since, human race has begun, we have been constantly inventing new things, yeah, and we are constantly looking into improving them. And it is no different with computers and technology. So, the programmers or the computer scientists were just not satisfied at this point, and they said that, well, the process of creating computer programs has to be even more easier and simpler for programmers. Because here as well, they thought that, well, yeah, you have to learn strange kinds of mnemonics or codes. Couldn't there be something that is similar to our everyday language, such as English? So, with this idea, when this came up to their mind, that resulted in creation of high level languages. Up till now, whatever we have seen are examples of low level programming languages. And by the way, low level programming languages are closer to the machine and not as close to the human programmers. Closer to the machine understandable form, let's put it this way, and not as close to the human understandable form. Now, if you were to invent programming languages in which you could write programming statements just like the way you write English words or sentences, wouldn't that be something that would come very naturally to you? Yeah? If you were able to use proper English words in your programming statements, proper English words, and some, punctuation marks such as a semicolon or speech marks and all that in programming statements, that would be something which would be natural to you or natural to your language that you use in your everyday life. So it was with this intention that computer scientists came up with high level programming languages. Now, by doing so, they made it very easy for the programmers, okay, human programmers, but it became even more difficult for the computers to understand. There would still be lesser processing needed to convert these into machine language, but what if the statements were totally in English or English like statements using proper English words? Wouldn't that be, moving it away from the hardware, okay, and making it very close to the humans? Yeah, exactly. Exactly. So the point is the same, that, well, we have translation programs. We have translation programs. So one translation program that was then invented to be used with high level programming languages is what a compiler is. So what is a compiler? Compiler is a translation program that is used to convert instructions written in a high level language into machine code so that the computer could understand and execute or run the statements. Make sense? So, had I not given you all this background, it would have been very difficult for you to understand what is a compiler. So, it had to be done so that you understand where is it all coming from, what is a computer program, what are programming languages, what are their categories, low level, high level, what is meant by a low level programming language, language that is closer to machine, okay, what is meant by a high level language, language which is closer to the programmer. But there are, of course, their own advantages and disadvantages. So advantage would be closer to us, easier for us to use, but difficult for the machine to process. But, well, there is a solution in between, which is to make use of a translation program that would do the job for us, do the job of converting one form of language into another for the computer to be able to understand and process. Now, what does it say here? Let's see. Now, when we go over the description given here, I think it will make sense to us. Software that translates programs written in a high level language code HHL into machine code that can be run on a computer. Do we understand this statement very well now? If I had read it directly, you would have had a lot of questions. You would have asked me, what is translation? What is a high level language? Okay, what is meant by machine code and what not? Yeah, okay. Two more terms that I would like to introduce here, and those terms are source code and object code. What are these? Listen carefully. When I tell you what they are, based on all the background that we've had so far, I'm sure you'll understand what they mean. Well, the term source code is used or is also used for the program that is written in any high level language. So the high level language version of a program can also be called the source code. As long as it is in high level language, you can call it the source code. When a high level language program is translated into the machine code or the binary language, that machine code or binary language version of the program is also called the object code. Source code, the original high level language program, may also be called the source code or the source program. When it goes through the translation process, gets converted into the machine code, that translated version of the program into machine code can also be called the object code. And by the way, this is also mentioned in your book. These two terms, source code and object code, are mentioned in the book as well. Okay, so many of the names that we just took, or we just came up with at the start of this discussion. Python is a high level programming language. Java is a high level programming language. VB, a Visual Basic, is a high level programming language. C++, C are high level programming languages. JavaScript is a high level programming language, etc., etc. So this means what? Largely the kind of programming languages that we are using these days to create all sorts of computer programs are actually high level programming languages because they are closer to a language which is understood by us, because we have the luxury of making use of translation programs that will do the job for us. All right? Is it clear? Any questions? All right. Okay, so the last example in examples of system software is a linker. All right, let's see what is a linker. Now, this time around, I'm going to go over the description of a linker straight away because the kind of terms that have been used in the description, you already know them, because I just described what those terms are. And so I'm going to sort of first go over the brief description that has been given about what is a linker or what are linkers, and then I'll explain it further. Okay, so it says software that takes a number of object files and combines them into a single program. I just explained to you what is an object code. So where it says combines, takes a number of object files, referring to the object code. Yeah, combines them into a single program. Now, what is he talking about here? Again, a bit of a background, and then we can link it up to the description that has been given here. Well, when computer programs are created, it is not a case that one or two programmers will create the entire program, especially when uh, programs are developed or softwares are made at a professional level. In large, big software houses where they make all sorts of programs that are usually going to be used for some sort of a professional purpose. Now, such programs are usually large programs, they're big programs, and they have a lot of functionality in them. Now, when I say functionality, what I basically mean is that a program that is able to do many different things. One program that has many features to it, that has many parts to it, okay, and every single part of the program does something which is part of the overall functionality of the program. All right. So, what do software development companies do? They basically break up the program into smaller modules. They break up the program or the program development process into smaller modules and then assign those modules to teams of programmers. So, say for instance, one team will be working on one part of the program, another team, which may have maybe two, three programmers, will be working on another one, and then another one that would be working on the third module and then the fourth module. All right? So, different modules or the whole program divided into smaller modules, different modules, each module assigned to a certain group of programmers, okay? And all of them parallelly working together on their own individual modules. But remember one thing, that all those modules are part of the same program. It's just that the program development process has been divided into parts assigned to different sets or different groups of programmers. When you do a larger task like this, you break it up into smaller parts, what is it that you are actually trying to achieve? Why would you do that? Any idea? Sorry? You think it will save time? Okay, that could be one. It can save time of development. Any other benefit or purpose that you see that can come with it? Okay, you can say it is probably more organized. Anything else that comes to your mind? More efficiency in what way? Um, okay, let's put it this way. When you're confronted with a larger task, okay, it might seem to be very overwhelming to begin with. And you might struggle to decide, where to start, where to end, and how to go about it. So what do you do if you're confronted with a greater problem or a big task? Well, it is always a good idea to break it up into smaller parts. Now, when you break up a larger problem or a task into smaller parts, it becomes easier for you to manage it. Because what you can, and then you also divide those smaller tasks amongst people or amongst different groups of people. So one group can focus on one sub-task or smaller task at a given point in time. Another group can focus on another one and so on. What would this do? It will allow you to focus on one small part properly and do justice with it. Sorry? Yes, because you will have your concentration going. You will be more focused because you are not looking at the bigger thing and getting yourself confused about it. You are focusing on one particular aspect or segment or module at one point in time. So your concentration will be better, your understanding will be better, you will be able to manage it better. Now imagine if the whole program is divided into four parts being managed by four different teams of programmers. Then one thing that you would notice is that the program development process is taking place simultaneously or parallelly. Every group of programmers working on their own chunk, working on their own module. And the entire program is being developed at the same time because all of them are working on their own modules and bringing them up. And then a time would come when all of them would have finished with their own individual modules. Now, at this point in time, you will need to do one thing, and that is to take all those modules and combine them into a single program, because you had only split it up for the sake of managing it better, making it easy, less time consuming, fewer errors. Okay, you wanted to achieve all that. But at the end of the day, remember that it is actually one program. So there will be a time where you will have to put them all together into a single program and then use it. What is a linker? Linker or link editor, the example that we are looking at, the last example of a system software, the purpose of a linker is to combine all the separate object programs into a single file for it to be now run and tested. Now let me show you a picture. This will explain a lot of things or make things much more clear. Now have a look at this diagram. Well, according to what I just said, you split the program into four parts. Okay, this is one module, this is another module, this is another module, this is module number 4. All these four are being developed by four different sets of programmers. One whole program split into four parts. This team creates their own source program, which is a high-level language program. This one creates their program, and so on. Every team creates their own high-level language program, which can also be called the source program or the source file. Remember, I was telling you about what is a source file, what is a source program, what is an object program, or source code or object code. So source code, object code, source program, source file, object file. one and the same thing. Yeah. So all these will have to be compiled to convert them into object files. So this gets converted into its own object file. This gets converted into its object file. This one, this one. All these source files, individual modules get converted into their source file, their object files, which is the machine language version of the program or the translated version of the program. Now, although all these separate parts of the program or the modules have been developed separately and have now been converted or translated into the object code or the object file or the machine code, the whole program has to still be run and tested as one single thing. So, here comes in the linker. What is the task of this type of a program, which is an example of system software? The linker would collect or put together all these individual object files into a single program, okay, and then execute the program to test it as one program. This is what the job of a linker is. Is this clear? Any question, any confusion? Okay, that's very good.